2024 A-Level Combined Mathematics Paper 1 Part B, question number 15, Part B. Part A of this same question was discussed in a previous video, link in the top right, and Part C of this same question will be discussed in a future video, link in the top right. Part B of this question has to do with integration using u substitution and integration by parts. The question says, using the substitution u equals x plus the square root of x squared plus 3, show that the integral from 0 up to 1 of 1 over the square root of x squared plus 3 dx is equal to 1/2 of the natural logarithm of 3. It then asks us to let j be equal to the integral from 0 up to 1 of the square root of x squared plus 3 dx, and then using integration by parts asks us to show that 2 times j is equal to 2 plus the integral from 0 up to 1 of 3 over the square root of x squared plus 3 dx. After that, it finally asks us to deduce that j, the integral, is equal to 1 plus 3 over 4 times the natural logarithm of 3. Now, to start off with this question, the first thing we need to do is use this substitution to turn this integral into an integral in terms of u and du. So considering this, we can first write out the substitution, which is u equals x plus the square root of x squared plus 3. Now, in order to do the substitution, we need this, but we also need to find du by dx, and we need to find the two values of u, the first value of u at x equals 0, and the second value of u at x equals 1, in order to replace the limits in our integral. So considering that, we need to find du by dx, and also after that we need to find the value of u when x equals 0, and the value of u when x equals 1. So starting off with the first one, if we consider du by dx, what we need to do is to differentiate both sides of this equation. So considering the left hand side is going to be du by dx, and considering the right hand side, we need to find the derivative of x, which is 1, plus the derivative of this term right here, which if I write in power form is x squared plus 3 to the power of a half. Now here we can see we have a function on the inside, and we're applying another function, the power of a half, to that function. So considering the functions of the form f of g of x, we know that the derivative is going to be equal to g prime x times f prime of g of x. Now considering this, the g of x is x squared plus 3, and f prime, or rather the f function, is f of x equals x to the power of a half. Now according to this, what we need is to find the derivative of x squared plus 3, which is the internal function, to the power of half, which is the external function's derivative, which is going to be equal to g prime x, or the internal function's derivative, which in this case is going to be the derivative of x squared, which is 2x, plus the derivative of 3, which is going to be 0, so just 2x, times f prime of g of x. Now considering f prime x, fx in this case is x to the power of a half. Since we input g of x, which is x squared plus 3, we are taking the power of a half of that function. So therefore, we have x to the power of half, and as we know, whenever you have x to the power of n, the derivative is n x to the n minus 1. So considering that the derivative here is going to be half times x to the power of half minus 1, or negative half. So therefore, f prime of x is going to be this. So considering that, what we have here is f prime of g of x. So therefore, we have half, and instead of x, we have to substitute g of x, which is going to be x squared plus 3 to the power of negative half. So therefore, this is the derivative we get when we take the derivative of the square root of x squared plus 3. Now considering this, we can see we have a negative power of a half, which is 1 over the square root of that value, and therefore if we simplify this, we can see we can cut the 2 and the half, leaving us with x, and then this thing turns into 1 over x squared plus 3 to the power of a half, which is going to be equal to the square root of x squared plus 3 on the denominator. So therefore we get this term right here. The derivative of the square root of x squared plus 3 is equal to x divided by the square root of x squared plus 3. So replacing that, we can see du by dx is equal to 1 plus x divided by the square root of x squared plus 3. Now before we write this off, we can see we can do one more thing, and that is to take this part right here as the common denominator. So doing so, we can see we can write the common denominator of the square root of x squared plus 3, and we can see we have x on top, but we also have this 1 that we have to take onto the top, and we can see in order to turn this 1 to have a denominator of square root of x squared plus 3, we have to multiply and divide by the square root of x squared plus 3, meaning that the 1 turns into a square root of x squared plus 3, so we have x plus the square root of x squared plus 3, and you'll note this thing is exactly what u is. So therefore, as a final term, we can write this as being equal to u divided by the square root of x squared plus 3. So according to this, du by dx is equal to u divided by the square root of x squared plus 3, and therefore 1 divided by the square root of x squared plus 3 is equal to 1 over u du by dx. And this is going to be extremely useful because we can use this in order to get rid of this 1 over square root of u squared, or rather x squared plus 3 that we have in this integral. So now finally, before we can substitute, we also need to find the values of u when x equals 0 and x equals 1. So we can go down here and say when x equals 0, and we can find the value of u, and we can also do when x equals 1 and we can find the value of u. So for x equals 0 we have u equals, and here we have x plus square root of x squared plus 3, which is going to be 0 plus the square root of 0 squared plus 3, which is just the square root of 3. So the answer here is square root of 3. Now considering the upper limit, we have u equals x plus square root of x squared plus 3, which is going to be x equals, or rather u equals x, which is 1, plus the square root of 1 squared plus 3, which is going to be 2, since the square root of 1 squared plus 3 is the square root of 4, which is 2. So therefore we have 1 plus 2, which is 3. So therefore the lower limit is root 3 and the upper limit is 3, and using these we can substitute and say the integral from 0 up to 1 of 1 over square root of x squared plus 3 dx, integral from 0 to 1 of 1 over square root of x squared plus 3 dx is equal to, and we can substitute, the lower limit is root 3, the upper limit is 3, and on the inside we can see, since 1 over x squared plus 3 is equal to 1 over u du by dx, we can replace the 1 over x squared plus 3 dx with a 1 over u du, and therefore all we have left here is a 1 over u du. Now simplifying, we can see 1 over u du is going to be equal to the natural logarithm of the absolute value of u, and therefore what we have here is the limits of the natural logarithm of the absolute value of u taken from root 3 up to 3. Now evaluating this, we can see this is just equal to the natural logarithm of, on top we have modulus of 3, which is going to be equal to 3 since 3 is positive, minus the natural logarithm of the square root of 3. Again, since square root of 3 is positive, we can ignore the modulus. So therefore what we have is natural logarithm of 3 minus natural logarithm of root 3, which we can see is equal to natural logarithm of 3 over root 3, which is just root 3 from index rules. As we know, natural logarithm of a minus natural logarithm of b is equal to natural logarithm of b over a, and 3 over root 3 is simply equal to root 3. So therefore what we have here is the natural logarithm of root 3, and we also know that this is equal to natural logarithm of 3 to the power of a half. And finally, we know that if you have natural logarithm, or really any logarithm of a to the power of b, this is equal to b times the natural logarithm of a, and therefore we can finally say that the answer here is 1/2 taken to the front times the natural logarithm of 3. So the answer here is 1/2 natural logarithm of 3. Now with that, we have completed the first part of the question. Moving on to the second part, it says, let j be equal to the integral from 0 up to 1 of the square root of x squared plus 3 dx, and it asks us to use integration by parts to show that 2 times j is equal to 2 plus the integral from 0 up to 1 of 3 over the square root of x squared plus 3 dx. Now in this question, what we have to do is to convert this function into the form u times v prime, where u is one function and v prime is the derivative of another function v. Now the reason we have to do this, of course, is because if you consider integration by parts states that the integral of u times v prime, where u is one function and v prime is another function's derivative, is equal to u times v minus the integral of the first function's derivative u prime times the second function v. Now this of course comes from the fact that if you take the product rule states that if you have two functions products u times v, the derivative of this is equal to uv prime plus u prime v. Now turning this around and integrating both sides, we can eventually get that the integral of uv prime is equal to uv minus the integral of u prime v. So in this particular case, what we have to do is to convert the integral that we have into the form u times v prime, where u is one function and v prime is another function, and then we can apply uv here minus integral of u prime v in order to simplify the function down. So considering our integral, we have j equal to the integral from 0 up to 1 of square root of x squared plus 3 dx. So we can write that down as the square root of x squared plus 3 dx. Now in this case you might notice that we don't seem to have two functions u and v prime. We only really have a single function, which is this square root of x squared plus 3. Now in this case, and quite commonly in these questions, you will have to take one of the functions as being equal to 1. What we'll have to do here is to write this integral as being equal to the integral from 0 up to 1 of the square root of x squared plus 3 times 1 dx. And when we do this, we have to take u as being one of these two functions and the other function or the other function's derivative as being equal to 1. In this particular case, what we need to do is to take u as being the function that's easy to differentiate since we have to find its derivative, and we have to take v prime as being the function that's easy to integrate since we need to find v. So in this case, we already found the derivative of the square root of x squared plus 3. It is equal to x divided by the square root of x squared plus 3. So due to that, out of these two functions that I have, the original function and the one that I've introduced here, I would like to take this as being u because I already know u prime. And with that, I could take this other function as being v prime, and I easily know how to integrate 1, so therefore this is not a problem. So what I'm going to do here is I'm going to let u be equal to the square root of x squared plus 3. I'm going to let v prime be equal to x, and in this case, in order to use integration by parts, I also need to find based on u prime, and also based on v prime, v. So considering that, for u prime what I need to do is to take the derivative, and as I already did that above, I'm just going to substitute that value in. I found the derivative of this is simply equal to x divided by the square root of x squared plus 3. Now similarly, knowing v prime, I need to find v, and to find v all I have to do is to integrate v prime, and I know the integral of 1 is simply equal to x, or actually I made a mistake here, v prime is equal to 1, as I chose here, and therefore v is going to be equal to the integral of 1, which is x. I accidentally mixed up v and v prime. So there we go. V prime is equal to 1, and the integral of 1 is simply x, so therefore v is equal to x. Now given this, what I can do is to use the integration by parts here and substitute in u and v and u prime and v, and write that j, which is the integral from 0 up to 1 of square root of x squared plus 3 times 1 dx is equal to, and I can write uv minus the integral of u prime v. So uv is this term times this term, which is x times the square root of x squared plus 3, and in this case, since this is a definite integral, I need to evaluate this from the limits of 0 to 1, and then minus the integral of u prime v, which in this case is the integral from 0 up to 1 of u prime, which is x over square root of x squared plus 3 times v, which is another x, which is going to give us x squared divided by the square root of x squared plus 3 dx. So here we can see, if we evaluate, we have j being equal to, and over here we have x times square root of x squared plus 3 from 0 to 1. When we have 0, this is going to be equal to 0, since this x at the front is going to be equal to 0. Cancelling that, if we take a look at the upper limit, which is 1, we have 1 times the square root of 1 plus 3, which is going to be equal to 2, and therefore we have 2 minus the integral from 0 up to 1 of x squared divided by this thing, which what I'm going to do is a little clever thing. I'm going to write this as instead x squared plus 3 minus 3 divided by the square root of x squared plus 3 dx. Now the reason I'm doing this is because you can see this term and this term is exactly equal to the square of the square root of x squared plus 3. Due to that, I can take the two terms and separate them, and if I do that, I'm going to get j equals 2 minus the integral from 0 up to 1. And here, if I take these two terms, I'm going to get simply this thing square root on top. Since if I divide this thing by its square root, I'm just going to get square root, which is square root of x squared plus 3 dx. And for the other part, I have minus 3 divided by this thing, which will be equal to plus the integral from 0 up to 1 of 3 over the square root, actually I missed a dx there, I accidentally erased that, dx divided by the square root of x squared plus 3 dx. Now the reason I did this is because if you go up, you can see j is equal to the integral from 0 up to 1 of the square root of x squared plus 3 dx. And going down, we can see over here we have the integral from 0 up to 1 of the square root of x squared plus 3 dx, which is exactly equal to j. So due to this, what I have here is j equals 2 minus j plus the integral from 0 up to 1 of 3 over the square root of x squared plus 3 dx. So considering that if I take the j to the other side, you can see we're going to get 2 times j being equal to 2 plus the integral, and what I'm going to do here is to take this 3 outside and write 3 times integral from 0 up to 1 of 1 over the square root of x squared plus 3 dx. Now this in itself is one of the answers. We wanted to show that 2 times j is equal to 2 plus the integral from 0 up to 1 of 3 over square root of x squared plus 3 dx. Now finally, what we need to do is to deduce that j is equal to 1 plus 3 over 4 times natural logarithm of 3. Now in order to do this, what we're going to do is to use this result that we found earlier, where this integral is equal to half of natural logarithm of 3, and substitute it into here. As you can see, if we take the 3 out, we have the integral from 0 up to 1 of 1 over the square root of x squared plus 3, and that exact integral was previously found to be equal to half natural logarithm of 3. Therefore, if we go down, we can see we have 2j equal to 2 plus 3 times, and this thing right here is equal to 1/2 natural logarithm of 3. Now with that, we can see if we divide everything by 2, j is equal to 2 over 2, which is 1, plus, and here we have 3 over 2 divided by 2, which is going to be 3 over 4, times the natural logarithm of 3. And with that, we have completed this question. Finally, let's discuss the marks awarded for this part of the question. So at the start of the question, when you're given the substitution and you use it to find du by dx in terms of u and find that it's equal to u over the square root of x squared plus 3, finding that gets you 5 marks. After that, when you find the two limits of u corresponding to limits of x and find x equals 0, u equals root 3, x equals 1, u equals 3, you get 5 marks for those two. Now after that, when you use that knowledge and the knowledge of substitution to convert our integral into the integral root 3 to 3 of 1 over u du, you get another 5 marks. When you solve that integral to find that it's equal to natural logarithm of modulus of u from root 3 to 3, you get another 5 marks. And finally, after applying the limits, when you simplify it down to being equal to 1/2 times the natural logarithm of 3, that gets you another 5 marks. Now after this, for the second part of the question, when you apply integration by parts, for applying integration by parts properly, selecting the u and v prime and all of that properly, and getting this line right here where you have everything substituted, for getting this line where you write it as this, which is then equal to uv, limits from 0 to 1, minus the integral of u prime times v from 0 to 1, getting that correctly gets you 10 marks. Now after that, when you simplify and get this form, and then when you take the x squared and subtract and add a 3 to that in order to get these two to cancel out like this, writing that out gets you another 5 marks. After that, when you take those two terms out like this as 2 minus this integral plus this other integral, and then you convert this integral into j like this, doing that conversion correctly and all of that gets you another 10 marks. Now after that, when you then take the minus j to the other side and write that 2j is equal to 2 plus 3 times this integral, that gets you another 5 marks. And finally, when you then use the value of that integral and you substitute it in to get that j is equal to 1 plus 3 over 4 times natural logarithm of 3 by substituting in that value as 1/2 times natural logarithm of 3, doing that gets you another 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.